So let's see if I can pop him off gently. And the answer would be a resounding no. Well, some of the pins came up, just not all of them. Well, second try I got most of it out. Socket's pretty much destroyed. Doesn't really have any value to me, so in the trash it goes. There's the last two pins. Okay, so now that I've done that damage, it's much easier to see where these traces go. Which they look like they just... So this trace right here is plus LED, you know, so LED supply voltage. These two traces here hit these resistors, so this one, yeah, they only go to the resistors, which go to +5. And then the other side of those go up to this chip right here. I'm wondering if this is just some sort of LED expansion port. So maybe they had another little display card of LEDs that went, let's say, over this area or over here. So this was your base function screen stuff, and then they could put an expanded one on that gave you more functions. Again, totally just a guess, because we don't have the original to go off of. We have to trace that out and see where they go. It sort of zips its way across the card. That goes to there. It goes to that, which is +5 volts. So 5 volts. There's definitely some connections. 1, 2, 3, 4. 1, 2, 3, 2, pin 4. So let's grab the data sheet for him again. Pin 4. 4 is an input. That's interesting. 2, 3, 4. Oh, pin 5. I can't count. Pin 5 is an output, so that makes sense. So this 273 here was feeding data out this connector. I'm assuming this connection here is ground since it goes to the minus side of a cap, and yeah, that's the main ground. So you had +5 volts, ground, LED power, some random little pull-up resistors I need to trace back, and outputs from this 273 octal latch. So pin 5 went to that pin, which he then went over to a resistor. So I'm guessing these are pull-ups for this connection. So when this guy was gated, these guys would hold the bus in whatever state it was last in. Now one of these IOs goes to this hole here. I'm assuming goes somewhere underneath this guy, because I don't see it coming out this end, and I see it coming in here. And that is the tape busy LED. And then these two here go nowhere. So there used to be a little 3-pin header, you know, just from the size of these pads and their spacing. I bet there's a ribbon cable header here that could be expanded to something else, which was never populated on this card. Let's see, does any of these other ones go anywhere important? Won't see anything. These go down to there. So now the back side of this chip. So there you got two sets of inputs. They wrap around and come up here, which hooks into the bus for these chips. And then you got these sets of four inputs here, which wrap around to this cluster here, which we need to... We haven't looked at these, but this set here and this set here look to be Terminator resistors for this long bus feeding all these 273s. So we'll have to sit down and beep that out next. But looks for all practical purposes, this chip here is just redriving that bus. Now, pin 1 and pin 11. I think it's 1 and 11. Let me double check that. Yep, 1 and 11. So 1 and 11 are your two important bits on here. 1 is your enable, or your clear, which when low turns all the outputs low. And pin 11 is your clock. So when clock is going high, it picks up whatever values on the bus and puts it on the output side. So pin 1 is hooked to pin 1, which is then hooked to power. So 1 is always high. So we can never clear this latch. And pin 11, which is this far corner here, wraps out and around. Kind of difficult to trace. One, two. Yeah, it just sort of goes all the way back to this 183. Now, 183 is a 3 to 8 decoder. There it is. So what this guy does in life is there's some enable logic that goes with it, but for the most part, it takes 3 bits, which you can code 0 through 8, and turns on one of 8 outputs based on the encoding. So low, low, low turns on Y0. High, high, high turns on Y7. So you can see the nice little diagonal line of bits across there. Now, depending on the enables, depending on how the enables are set, it sort of negates the output no matter what the select lines are. So this 138 right here is the address demultiplexer for this guy. So looking at this, what's going on right here, I can easily lose him and these, and it won't affect the LED operation. Since I don't know what this connector is for, nor do I have what plugs in there, he's going away. He's just basically chewing up electricity. So back to the desolderer I go. Okay, I was not getting these hot enough to reflow the solder on this side completely, so this chip might be a little bit of a trip to get out. I'm actually going to turn my heat up a little bit. Yeah, you still soldered it. I don't know. It looks pretty clean, actually. Oh, there it goes. Ta-da! Didn't break any legs off, and I have an extra 273 in case I need it. Oh! Okay. 4700, so these are 47K pull-ups. They're going to disappear as well. Okay, this side, you got this big copper bus bar, so it takes quite a bit more heat in order to get the solder to melt. So, when you run into that situation, especially when you got some sort of gloopy solder like this, one thing you can do is just add a little more solder to the backside, so your iron has a better connection, thermal connection. Between the iron and the pad. Oh. So now let's pop those resistors out. I popped one other resistor out of here. Make a different pile of resistors. Now I could have just clipped the leads off. You know, clipped the body off, left the leads there, but that looks a little hokey. It doesn't take me that long to desolder stuff. I got a nice desoldering iron, so that's what I'm going to do here. And also, you never know, I might need one somewhere else in this car, and then I can just pick it up and go. This is a filter capacitor. I assume it's in good condition still, but that said, this thing is pretty dang old. So before I'm done, I'm gonna probably pop all these caps off and test their value and their leakage, and if any one of them is really leaky or off value, I'll just replace them at that time. Once you're done unsoldering stuff, just make sure you don't have any little solder shorts left over. So I'm going to leave this here and go back and do some more tracing. So one of the things I just noticed and pointed out was these Terminator Banks. So first things first, let's figure out which side's power and which side's ground. So let's grab there, because that's power. Or at least as far as I can tell, it's power. Okay. So this side is plus 5 volts. So I'm going to go and that is orange, orange, brown, so 330. 2, 2, 3, 3. Yep, 330. And I'm guessing this side goes to ground, just based on what I've seen out where. Yep, and that's 470. 470. Now, I don't know why the designers picked this, but this voltage divider here is going to try and pull this bus to a little over the midpoint. So you're going to have 470 plus 330, so 800 ohms, so 5 volts divided by 800 times 470 ohms. So about 2.93 volts. Give or take. Now, I think they did that to speed up the switching rate. Since they're pulling it to the midpoint of the switching area, when they drive high or drive low, they don't have to go very far. Versus had they pulled it all the way up to the top, to drive a high, it wouldn't have to move very far, but to drive a low, it'd have to swing farther down. So you'd get this sort of lopsided waveform justified up based at higher frequency rates. At slow rates, it'd use the whole thing, but at higher rates where you have the slew of the driver to take into account, you'd sort of see the waveform sort of slowly smush upward as your bus frequency increased. So we've taken care of this connection out to all the LEDs. Now the next part I want to do is trace these LEDs back into these drivers. I think what I'm going to find is since there's only 3 FETs here, or sorry, transistors here, and are they? Yes, they are the FPN 222s. I bet what I'm going to find here is these LEDs here are in groups of 3, or in 3 groups of however many, driven by these guys. Here's their biasing circuit, which does turn out to be the same as this. I checked that earlier.